Okay, time to continue with the second part of the revision. We'll begin with unsupervised learning, okay, which is the flow I'm using in the predictive modeling class. Okay, you should have applied the descriptive statistics in your assignment, so this will not come out in your final assessment. Okay, for dimensional reduction, okay, we have only discussed the principal component analysis, so there will be a question of 2 marks coming out in your final assessment. Clustering is a bit heavy. I think it's something like 8 marks or 10 marks on clustering. Okay, we never discuss association and time series. That is for other courses, so okay, it won't come out at all in your final assessment, but you can comment on them if you know anything about them. Okay, for principal component analysis, the data has to be numeric. Okay, it's associated with the normal distribution, and okay, the eigenvalues and the proportions of variance and also the cumulative proportion of variance, okay, are all associated with the eigenvalues of this covariance matrix C. Okay, for the eigenvector corresponding to the eigenvalue, okay, it's for finding the principal components. Okay, it's very important for the biplot. Okay, as you can see in R. Okay. Okay, so what kind of questions can come out? Nothing much, right? Okay, but most of the time, the eigenvalues or okay, the biplot, this kind of questions. Okay, k-means clustering. Again, the data has to be numeric. Okay, it has something called hyperparameters k. Okay, it's something we have to set. Okay, you can think of hyperparameters as something we have to set. Okay, not something which is trained. And we also need to decide on the distance measure. Okay, so what does this k-means clustering do? It actually partition points to clusters in k of them, okay, based on the distance. So in R, okay, basically it's something default. Okay, and the R actually only supports Euclidean distance. And if we need to deal with other types of distances, then we have to install other packages. Okay, there's some important parameters which okay, we mentioned in the practical class, but in final assessment, basically it's just direct calculation, okay, to get to the clusters based on updating the centers. Okay, so nothing complicated. Okay, next, hierarchical clustering. Again, unfortunately, it's only for numeric data. Oh, and the R hierarchical clustering input actually instead of taking the data and the distance measure, actually just takes in the distance matrix, okay, for the data. So after we apply the hierarchical clustering internally, it will be stored in something like matrix form. Okay, in order to see the clustering, okay, we have to construct a dendrogram, okay, for the distance matrix. So in summary, okay, in R we just have to use the basic function in R, okay, called dist, okay, and we supply with the method Euclidean, then we can generate this distance matrix. Not exactly a distance matrix because it's actually just half of the matrix, and it actually allows us to set other methods. Okay, and then the hierarchical clustering, the one we discussed in class, is the complete linkage, single linkage. Okay, we mentioned about average linkage, but okay, it's complicated to calculate, so it's not there in your final assessment. Others are not discussed in class, so it won't come out. Okay, so dendrogram, okay, we can just use the usual plot function to actually just plot the result, okay, return from hierarchical clustering function. And the hang is just to draw until the horizontal line. Okay, and then cut tree is not normally to split the clusters. Okay.